Hello dear students, welcome to ECE Academy Benefactor. In this class we will be saying classification of amplifiers. The topic is from feedback amplifiers and the subject name is ECE. So the classification is based on the magnitude of input and output resistances. Input resistance is symbolized by Ri, output resistance is denoted by R0. So, based on the magnitude of Ri and R0 of an amplifier relative to source and load resistances. Source resistance is represented by Rs, load resistance is represented by RL. So, the classification of amplifier is based on the magnitude of input output resistances of an amplifier relative to source and load resistances. In this class we will be understanding how to remember and draw each amplifier. In our previous class we have seen some basic equations regarding each basic amplifier, but in this class I will be trying to explain how to draw them and an easy way to remember each basic amplifier. So, as you know, there are 4 amplifiers: voltage amplifier where Ri is very large compared to Rs and RL is very large compared to R0. Second one is current amplifier of gain Ai. Voltage amplifier gain is AV. Current amplifier gain is Ai. Trans conductance amplifier is Gm and trans resistance amplifier gain is Rm. So, let us see how to draw them and remember them easily. So, first coming to voltage amplifier, I have to know its voltage gain equation. What is voltage gain of voltage amplifier? AV, which is known as voltage gain. Okay, what is gain? Gain is equal to output by input. What is voltage gain? Voltage gain means output voltage by input voltage. Okay. So, it is very clear. Based on this equation we can easily draw the equivalent circuit of the voltage amplifier. So, at the output side we need a voltage source and at the input voltage V0 is observed. At the input side we have to place a voltage source. So, for a voltage source the resistance is in series. So, let us see how to draw it. So, at the input side we will connect a voltage source Vs plus minus and this is a voltage source. So, we will connect a resistor. Okay, this is the input part. And at the output side we need to connect a voltage source. How much voltage source it should be? What is the equation? AV is equal to V0 by Vi. So, what is V0? V0 is equal to AV times of Vi. So, this much of voltage we need to place at the output side. So, we have placed a voltage, its value is AV Vi plus minus. And for a voltage source the resistor is in series. So, here we connect a resistor R0. This is the input side and that is the output side. At the output side we connect a load resistor RL. Okay. And at the input side we need an input resistor Ri like this. So, this is a voltage amplifier equivalent circuit. At the input side we need to ground it and at the output side we need to ground it this way. And what you are observing here? The output voltage V0 plus minus. So, this is how we have to draw the voltage amplifier. What is the condition for voltage amplifier? Ri is very large compared to Rs. This is very large and here At the output circuit, RL is very small compared to R naught. So, Ri is very large means what is Ri value? It is infinity. And what is the R naught value? RL is very large, है ना, very large. Sorry, there is a correction. RL is very large compared to R naught. So, what is R naught value? R naught is 0 ideally. So, this is how we can draw the voltage amplifier. Now, let us draw the current amplifier. The current amplifier gain is AI. What is AI? Is a gain. Gain means output by input. What is output parameter? It's telling clearly AI, current gain. Output current by input current. Okay. And what should be the A naught, I naught value? I naught is equal to AI times of II. So, based on this, now we need to draw the equivalent circuit of current amplifier. So, II means input side. So, we need a current source at the input side. So, place a current source Is. For a current source, the resistor is in parallel, whereas for a voltage source, the resistor is in series. So, we have placed a current source of parallel resistor, source resistor, Rs resistance value. This is the input circuit. And at the output circuit, what we need to place? A current generator. So, we place a current generator, this one. What should be this value? Its value is AI times of II. As there is a current generator, we need to use one resistor R naught in parallel. At the output side, we observe the voltage across the load resistor RL, and at the input side there is a resistor Ri. So, where is the current II flowing? Here. Here there is a current I naught is equal to IL. Okay. And the input is to be grounded and the output circuit is also to be grounded. So, how can we decide this one? Based on this equation. So, what is the condition for current amplifier? Ri is very less compared to Rs, and RL is very less compared to R naught. So, if Ri is very less means ideal value Ri is 0. RL is very large means R naught is infinity. So, in this way we can draw the current amplifier. Now, let us see how to draw the transconductance amplifier. The gain of transconductance amplifier is GM. GM means the reciprocal of resistance. What is G? Is reciprocal of resistance. And what is resistance? V is equal to IR. So, R is equal to V by I. So, what is G equal to? G is equal to I by V. So, what is GM equation? GM is equal to I by V. So, it is output by input. So, output is I means I naught, input is Vi. Okay. So, at the output side we need a current generator and at the input side we need to place a voltage source. So, let us place the voltage source, this is voltage source Vs plus minus a voltage source Vs. When there is a voltage source, a series resistor. This is the input circuit, and at the output side we need a current generator. What should be the I naught equation? I naught is equal to Gm times of Vi. So, we need to place a current generator here. What is its value? Its value is Gm Vi. As there is a current generator, we need to place a resistor R0. So, this is the output circuit. At the input circuit, we place a resistor Ri. At the output circuit, we place a resistor RL. The input side is to be grounded and the output is also to be grounded. So, where is Vi observed? It is observed here, Vi plus minus. Okay. And where is the current I0 flowing? This one, I0 is equal to IL. So, here Ri is very large compared to Rs and R0 is very large compared to RL. So, ideally Ri is infinity and R0 is also infinity. Ri is infinity and R0 is infinity. Let us now see the fourth amplifier, that is trans resistance amplifier. Trans resistance amplifier gain is Rm. What is Rm equal to? R is equal to V by I. So, output by input. Output is V. V means V0. Input is current II. So, what is V0 value equal to? Rm times of II. So, at the output side we need to place a voltage source. At the input side we need to place a current source. So, place a current generator here, current source Is. This Is, there is a current source Is, so there will be a parallel resistor Rs. This is the input circuit. At the output circuit we need to place a voltage source. What should be that voltage source value now? That should be Rm II. As there is a voltage source, there will be a series resistor R0. This is the output circuit. At the input circuit we need to place a resistor Ri. At the output side we need to place a resistor, load resistor RL. Now make it ground. Input side is to be grounded and the output circuit is also to be grounded. And what is Ri value? Ri is very less compared to Rs and R0 is also very less compared to RL. So, as it is very less, Ri will be 0, R0 is very less, so R0 is 0 ideally. Okay. So, it is easy to remember these circuit diagrams. So, we need a current II. So, where is the current II here flowing? The current II is flowing in the input circuit. Okay. And you can observe the output voltage across RL. This is plus minus. Okay. So, in this way you can easily draw all the 4 basic amplifiers which you will be requiring while doing the analysis of feedback amplifiers. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.